Everything that begins to exist must have a cause. This simple axiom underlies every scientific theory, every chain of reasoning, every human attempt to make sense of the world. Yet the universe itself, time, space, and causality included, had a beginning. So if everything needs a cause, what caused the beginning? The paradox is immediate and merciless. To explain existence, we must invoke something that lies beyond existence itself. Physics pushes this boundary with precision, and philosophy exposes its fracture. The Big Bang model tells us the universe expanded from a singularity roughly 13.8 billion years ago, a point where known laws of physics collapse. But a singularity is not a thing in space. It is the breakdown of space. To ask what came before, it is to misuse the word before, because time itself emerged with that event. The question of what caused the universe is thus forced to look for an answer in a domain where cause has no meaning. Some argue for a first cause, an uncaused origin that exists necessarily, not contingently. Others propose quantum cosmology. Perhaps universes arise spontaneously from fluctuations in a quantum vacuum. Yet even the vacuum is not nothing. It is a field governed by laws that must themselves exist. Whatever we name as the source only relocates the mystery one step higher. The paradox is not that we lack an answer. It is that our concept of causality, our deepest tool for explanation, breaks precisely at the point where explanation matters most. The origin of everything cannot be explained within everything. To understand the beginning, we must question the logic that allows beginnings to exist at all. Causality is the spine of reason. Every event follows from another. Every effect implies a cause. From planetary motion to chemical reactions, this chain defines the universe as a vast network of dependences. Yet when we trace that chain backward, the logic that sustains it begins to dissolve. Physics can describe how events unfold, but at the moment we reach the origin, it loses the very framework that makes unfolding possible. At quantum scales, causality itself becomes statistical, not absolute. The decay of a radioactive atom has no specific trigger. It simply happens, governed by probabilities rather than deterministic causes. The classical idea that every effect requires a prior cause already fails inside the atom. Now imagine extending that logic to the birth of the cosmos. What if the universe, too, is a quantum event, an uncaused fluctuation within a field of pure potential? The laws of nature might not produce the universe. They might permit it. Stephen Hawking suggested that when we describe the universe with quantum gravity, time behaves like a spatial dimension near the origin. There is no before the Big Bang because the universe did not begin in time. It included time as one of its emergent properties. The question, what caused the Big Bang, becomes as meaningless as asking, what's north of the North Pole? The paradox is that causality itself may be a feature inside the universe, not a principle that governs its creation. If so, the first cause we seek does not exist before the universe. It exists as the universe. The chain of causes does not start. It loops back into the laws that define it. The beginning, then, may not be an event at all, but the moment reality realized it could exist. When we say the universe came from nothing, we imagine a void, silent, empty, and absolute. But physics reveals that true nothingness does not exist. The quantum vacuum, often mistaken for emptiness, teems with fluctuating fields. Particles appear and vanish, borrowing energy from uncertainty itself. Even in total darkness, creation and annihilation never stop. This is not nothing. It is the restless potential for everything. Quantum cosmology takes this further. According to models like the Hartle-Hawking no-boundary proposal, the universe could emerge from a quantum state where space and time are indeterminate, not zero, but undefined. In that state, the concept of before and after does not apply, because time has not yet crystallized into sequence. The Big Bang, then, is not a creation out of nothing, but a transformation within possibility. The universe was not born into space. It is what space became when potential condensed into existence. But if nothing is filled with fluctuating laws and quantum fields, then those laws themselves must already be. Why do they exist at all? Why does the void obey mathematics? The paradox deepens. Even a universe from nothing presupposes a structure that defines what nothing can do. The void is not empty, it is governed. It follows rules it did not choose. What we call nothingness, then, is simply the absence of things, not the absence of order. Reality cannot escape the framework that allows it to be described. The true mystery is not how something came from nothing, but why the laws that permit that transition exist in the first place. The universe may not emerge from nothing. It may be the act by which nothing recognizes it as something. Time feels like the most fundamental dimension, a river carrying every event from past to future. But in the equations of physics, time is not absolute. It can bend, stretch, even slow to a stop under gravity's weight. At the Big Bang, it did more than distort. It emerged. The origin of the universe was not an explosion in time, but the moment time itself came into being. In Einstein's relativity, space and time form a single fabric, space-time. What we experience as before and after is just the unfolding of this geometry. But when space-time shrinks to Planck-scale dimensions, about 1035 meters, quantum uncertainty overwhelms geometry itself. The smooth continuum of time dissolves into probabilistic foam, a haze where sequence and duration no longer exist. Asking what happened before that moment is like asking what lies outside the surface of a sphere. The question loses meaning because the concept it relies on, time, has not yet formed. Some cosmologists propose that time is emergent, arising from entanglement and thermodynamic order. In this view, as quantum states decohere into classical reality, a direction, a past and a future, materializes. The arrow of time is not fundamental, it's the memory of increasing complexity. Before that ordering, there was no flow, no ticking of existence. And yet consciousness cannot imagine timelessness. We think in time, not about time. The paradox is that we use a temporal mind to comprehend a reality where temporality itself is not primary. The universe did not begin in time. Time began in the universe. What we call the first moment may be nothing more than the instant the cosmos learned how to count itself forward. Every event we remember unfolds in one direction. Eggs crack but never uncrack. Stars burn but never unburn. We grow older but never younger. This flow from order to disorder, from past to future, is encoded in the second law of thermodynamics. Entropy always increases. Entropy measures the number of ways a system can be arranged. Higher entropy means more possibilities, less structure. But here lies a silent paradox. The laws of physics themselves are time-symmetric. They do not prefer a direction. The equations work just as well backward as forward. So why does the universe insist on moving one way? The answer, it seems, hides in the boundary condition of the cosmos, the Big Bang. For reasons still unknown, the universe began in an extraordinarily low entropy state, exquisitely ordered, far more than any random configuration should allow. That improbable order became the reference point from which time's arrow emerged. Entropy increases not because the laws require it, but because the universe started improbably neat. The arrow of time is a memory of that cosmic asymmetry, a whisper of the universe's unlikely birth. But if the origin defines time's direction, then the cause of that low entropy beginning must lie outside time's domain. It cannot be explained by earlier events because earlier had not yet come into existence. Causality depends on time, time depends on entropy, and entropy depends on a beginning that cannot itself have a cause. The arrow of time, then, may not describe motion. It describes ignorance. We move forward because we remember the past and not the future. The universe's one-way flow might be nothing more than the shadow of our limited perception projected onto the surface of eternity. If the universe's birth defies causality, perhaps it never truly began. Several cosmological models attempt to dissolve the paradox by removing the notion of a singular starting point altogether. Instead of a single creation event, reality might be eternal, unfolding through endless cycles, or spawning infinite universes beyond our own. In this vision, the cosmos is not a line with a beginning, but an ocean with no shore. Cyclic cosmology suggests that our universe is one bounce in an infinite sequence of expansions and contractions. When a previous universe collapses under its own gravity, quantum effects could reverse the implosion into another Big Bang. In this picture, the cosmos never starts or ends. It breathes. Each cycle resets entropy, erasing the arrow of time before beginning again. The cause of our universe is not before time. It is time, recurring eternally. Yet even here, the paradox lingers. What set the first cycle in motion? An infinite regress of universes cannot explain why there is a cycle at all. The multiverse extends this escape further. Quantum fluctuations in a primordial field could spawn countless universes, each with its own laws, dimensions, and constants. In this framework, Our Big Bang was simply one bubble among infinite others. But infinity is not an answer, it is a postponement. To exist, the multiverse still requires the mechanism that allows universes to emerge, and that mechanism must already be. Every attempt to erase the beginning merely shifts its coordinates. Whether through cycles or infinities, we find ourselves circling the same invisible source, something that cannot itself be caused, yet gives rise to everything that is. The paradox does not vanish in eternity, it multiplies. Infinity does not solve the origin, it makes it permanent. At the quantum level, the universe abandons determinism. Events do not unfold because of prior causes, but according to probabilities. A particle does not decide to appear, it manifests with a calculable likelihood. The famous double-slit experiment reveals this most vividly. A single electron passes through two openings at once, creating an interference pattern that exists only when it is unobserved. The act of measurement collapses the wave of possibilities into a single outcome. In this world, cause is replaced by chance, and observation becomes participation. If the universe itself began as a quantum event, its origin might not require a cause at all, only a probability. According to quantum cosmology, the entire cosmos could be the result of a spontaneous fluctuation in a pre-existing quantum field. But probability requires a framework of rules, a mathematical substrate that defines how chance behaves. The paradox resurfaces. Randomness still presupposes order. Uncaused events still obey laws. Physicist Lawrence Krauss proposed that something can indeed come from nothing because quantum fields allow energy to appear and vanish in perfect balance. But the vacuum's balance is not emptiness. It is a rule book written in mathematics. Even in randomness, there is structure. The dice of creation still require a table to roll upon. This suggests a deeper truth. Perhaps causality and randomness are not opposites, but two expressions of the same underlying principle, the necessity of possibility. The universe exists not because it was caused, nor because it was random, but because the potential for existence could not remain unrealized. The ultimate law may not govern what happens, but ensures that something can. Quantum mechanics shattered the boundary between observer and observed. In the classical world, reality unfolds independently of who measures it. But in the quantum realm, observation creates the outcome. Before measurement, a system exists as a superposition of possibilities. Only when observed does it collapse into one. This principle, verified countless times in laboratory experiments, implies that reality is not merely there, it is brought forth by interaction. Applied to the cosmic scale, this insight becomes vertiginous. If the universe began as a quantum event, what, or who, performed the first observation? What collapsed the wave function of reality into existence? John Wheeler, one of the fathers of quantum gravity, proposed a daring idea: the participatory universe. In his view, the universe requires observers to bring it into being. Observation is not a later feature of evolution. It is woven into the fabric of existence itself. We exist because the universe observes itself through us. This does not mean human consciousness predates the cosmos. Rather, it suggests that observation, the exchange of information, the act of measurement, is fundamental. At the birth of the universe, quantum fluctuations interacted, entangled, and in doing so, observed one another. Reality began when interaction became information. In that instant, the potential became actual. From this perspective, consciousness is not an anomaly within matter, but an extension of the same process that initiated matter itself. Every act of perception continues the original collapse that created the world. The universe is both the object and the subject of its own observation, a self-measuring system that evolves by knowing itself. The paradox now tightens. If observers are necessary for reality, but observers emerge only after reality forms, how could the process ever begin? Wheeler called this the self-excited circuit, a closed loop in which the universe gives rise to observers, and observers give reality meaning. Cause and effect collapse into reciprocity. The cosmos bootstraps itself into existence through awareness. Perhaps then the question, what caused the universe, is misphrased. The universe was not caused, it was realized. Existence may not have a first cause because it is not a sequence at all. It is a feedback loop of being, a system where knowing and existing are the same act. In understanding itself, the universe completes its own creation. The mind seeks coherence. When faced with contradiction, it demands resolution. Either this or that, never both. Yet the cosmic origin paradox may reside precisely where logic fails, in a reality that is simultaneously caused and uncaused. Our reasoning depends on binary categories: existence or non-existence, cause or effect, beginning or eternity. But the universe's origin exposes the limits of those distinctions. It is the point where logic tries to describe its own birth, and in doing so, collapses. In classical reasoning, the law of non-contradiction is absolute. A statement cannot be both true and false. Yet quantum physics undermines that certainty. Particles can exist in multiple states at once, a superposition that remains contradictory until observation forces a decision. At the foundation of reality, contradiction is not error, it is structure. The universe is not built from clear categories, but from overlapping probabilities. When applied to the origin, this suggests something radical. The universe could be both the effect and the cause of itself. In certain models of quantum cosmology, space-time loops back upon itself through closed geometries, allowing a self-contained universe, one that originates from its own quantum potential. This is not circular reasoning. It is circular reality. Like a Mobius strip, existence may have only one continuous surface, appearing to have two sides, cause and effect, only from within. Philosophically, this breaks the very grammar of explanation. To ask, what caused the universe, presupposes that causality is external to it. But if causality itself is an emergent property of the universe, then the question folds inward. The cause of everything may not be something beyond, but the structure that allows beyond to exist. The universe could be self-explanatory not by escaping paradox, but by embodying it. In this view, contradiction is not the failure of understanding. It is the signature of truth at its deepest level. The universe is both dependent and independent, contingent and necessary, born and eternal. Logic, stretched to its limit, reveals its own origin as paradox. Perhaps this is why the cosmic beginning cannot be resolved through reason, because the act of reasoning itself began with it. We cannot use logic to step outside the event that created logic. The universe, in explaining itself, becomes the one phenomenon that must break the very rules it made real. If every attempt to find a material first cause collapses, perhaps the cause of the universe is not physical at all, but mathematical. Long before matter or energy, before time or space, there may have existed only structure, the logic of what could exist. In this view, reality is not made of stuff, but of relations, patterns, and symmetries, the grammar of being itself. Mathematics describes the universe with uncanny precision. From the orbit of planets to the behavior of subatomic particles, everything follows equations that seem to exist independently of the things they describe. Why should the cosmos obey math at all? Because, some argue, the cosmos is math. Physicist Max Tegmark calls this the mathematical universe hypothesis. Physical reality is not merely governed by mathematics. It is a mathematical structure. What we experience as space, time, and matter are emergent expressions of timeless relations among numbers and forms. If so, the question, what caused the universe, transforms. Mathematical truths do not begin or end. They simply are. The number p or the Pythagorean theorem did not have to be created. They exist necessarily in all possible realities. Perhaps the universe exists for the same reason, because the structure that allows it cannot not exist. Existence, in this sense, is not an accident but a requirement. This idea reframes the paradox. The universe may not need a cause because it is the realization of a structure that is self-consistent. Where causality fails, necessity begins. The Big Bang, quantum laws, entropy, even time itself, all could be emergent consequences of the only possible coherent mathematical system. The cosmos would not be designed or created. It would be inevitable. But inevitability is its own enigma. Why should logical possibility become physical actuality? Why should abstract patterns ever be? The transition from mathematical necessity to lived existence marks the final border of comprehension. Perhaps the universe is what happens when logic recognizes itself, when consistency becomes consciousness. In this framework, the cosmos did not emerge from nothing. It emerged from truth. The first cause was not an explosion in space, but the awakening of structure into reality. And that awakening never truly stopped. It continues wherever the universe becomes aware that it exists. Every path we've followed, through causality, quantum chance, time, and mathematics, converges on a single realization. The universe may not have a cause because it is one. The cosmic origin paradox dissolves not by choosing between cause and uncaused, but by revealing that existence is the only self-consistent state possible. What we call creation is simply the moment consistency became self-aware. Imagine the universe as a closed logical circuit. Within it, every event arises from another, yet the circuit as a whole has no external input. It sustains itself through coherence, each part defining the rest. Such systems exist in mathematics and physics: feedback loops, self-referential equations, stable attractors. The cosmos could be the largest of these, a self-exciting field where structure generates awareness and awareness stabilizes structure. Reality, then, is not an object, but an ongoing act of self-definition. Quantum mechanics already hints at this reflexivity. Observation collapses possibility into actuality, while actuality gives rise to new observers capable of further collapse. The universe builds itself from the inside out, one interaction at a time. No external cause is required, because the very distinction between inside and outside arises only within the system. The origin is not an event in time, but a condition of coherence, the point where reality became consistent enough to endure. Mathematically, such a universe could be viewed as the minimal solution to the equation of being, the simplest state that can contain its own explanation. Philosophically, it is the final self-reference, existence existing because non-existence is impossible. For nothingness to be absolute, it would have to exclude the possibility of existence, yet that exclusion itself would be something. The void cannot hold. Thus, the universe does not emerge from an external cause, nor from chance, nor from design. It emerges from the necessity of coherence, from the impossibility of not being. Every law of physics, every fluctuation of matter, every act of thought participates in maintaining that balance. The paradox resolves only when we see that the cosmos is not the result of a cause, but the expression of consistency itself. The first cause and the universe are the same phenomenon viewed from opposite sides of understanding. Existence is not explained by something else. It is the explanation. The paradox we began with, that everything must have a cause, yet the universe itself cannot, now stands transformed. The question no longer asks what started reality, but why the idea of a start exists at all. Causality, time, chance, and even logic were never external principles imposed upon the cosmos. They are internal languages the universe speaks to describe itself. From that view, the beginning was not an explosion or a boundary. It was the first act of coherence. The instant potential recognized itself as possible. The Big Bang was not the creation of existence, but the first realization of awareness, the moment the void understood that non-existence could not hold. Every particle, every law, every mind that arose after was the echo of that single realization continuing to unfold. When we search for the first cause, we imagine a moment that precedes all others. But what if the first moment never ended? What if the universe has been beginning now for 13.8 billion years, continuously recreating itself through the act of being observed, measured, and understood? The origin is not behind us. It is the ongoing pulse of existence within us. We are not outside the paradox trying to solve it. We are its living continuation, fragments of the universe contemplating the mechanism by which it came to be. The question, what started it all, may be the universe asking itself what it means to exist. And perhaps that is the final resolution. Creation never happened once. It is happening still. Write in the comments, I still exist in the moment that never began.